everyone, we're Group 18. Today we're here to discuss the AWS infrastructure tailored for AnyGroupLLC's expansion into New Zealand. This is our architecture diagram, starting with our foundational element, the Virtual Private Cloud (VPC). The VPC ensures that AnyGroupLLC's resources remain isolated and secure, forming a robust backbone essential for maintaining data integrity and reinforcing customer trust. For access control, all the external interactions directed through the Internet Gateway. This gateway ensures a steady and secure communication flow between AnyGroupLLC systems and the global customer base. We have boosted our security framework with two public subnets. The first houses our bastion host and the net gateway. This architecture ensures only authorized access while allowing our system to fetch essential updates securely from the internet. The second subnet with an additional net gateway improves our resilience. This redundancy ensures uninterrupted service, even if one gateway faces issues. Moving to our web tier, where most customer interactions occur. CloudWatch and SNS ensure real-time monitoring, proactively identifying and mitigating potential issues. This proactive approach guarantees an optimal customer experience. Our web servers integrated with S3 storage in the first private subnet ensures swift content delivery coupled with our auto-scaling group. This setup guarantees swift page loads and seamless scaling during high traffic periods, achieving cost effectiveness and performance. Diving into the web tier, here we handle data web requests across two private subnets. Private subnet 1 and 2 have been connected to DynamoDB, ensuring constant, fast, and scalable database operations. The integration with Amazon Elastic Cache with its master in one subnet and slave in another, ensure rapid data processing and retrieval, further enhancing user experience. Finally, in the DB tier, our data is central and crucial to our operations, distributed across two private subnets. It forms the backbone of our data management and operations. This store database setup ensures continuous data availability and integrity, even if one faces hiccups. In conclusion, our AWS infrastructure is designed to ensure high availability, swift performance, and top-tier security, making sure AnyGroupLLC stand out in the New Zealand market.
To walk you through our AWS setup, particularly focusing on our VPC configuration and security measures. Our VPC is named as this, and it covers comprehensive range with the address specified as this. Inside this VPC, we've set up multiple subnets spread over two availability zones. This ensures that even one zone faces issues, the other is there to back it up, preventing any major downtimes. And for the subnets, we have two public subnets for connecting to the world. Public subnet 1 is in US East 1A with this specific address. And another one is in US East 1B. It has a different address. These subnets are our major links to the outside digital space. And we've also created private subnets for our web, app, DB tiers, and also for the cache. Each of these sections has two subnets, one in each availability zone, covering address from this broader range. This design ensures that even if an availability zone experience disruption, our service continues seamlessly. For effective data routing, we've set up 3 route tables. A public route table, this is associated with 2 public subnets, targeting a specific internet gateway to connect them to the internet. And we also have a private route table. This is for our first group of private subnets, directing its traffic towards a NAT gateway. As for another private route table is for second set of private subnets that's located in a different availability zone. Our public subnets utilize an internet gateway, providing them with straightforward internet access. And our private subnets rely on 2 NAT gateways. NAT gateway 1 is tied to public subnet 1. These gateways allow them to safely make necessary outbound connections without directly exposing them to the vast internet. For security, we use NACLs to set up basic traffic rules. We have a default one allows all traffic from any source, making our system flexible. And we also have a specific one for our cache setup to ensure controlled and secure data transfers, which only allows TCP connections. And for security groups, the first 2 manage our load balancers and only allow standard web traffic. The next one is for Bastion hosts. This one only allows secure access. And the next 2 are for our web server and application, allowing only web traffic. And the last one is tailored for database, so only database specific traffic can get through.
We will recommend AnyGroupLLC to leverage AWS load balancers and auto-scaling groups to deploy your web servers and app servers in this architecture. The benefits are it makes sure your systems are always up and running. Even if one part fails, it automatically reroutes the traffic to keep things smooth, reducing any downtime. It's also cost-effective. You only use the resources you need, so you save money without sacrificing performance. As your business expands, this setup also scales with the business. First, we will create a load balancer at the web tier. You select the application load balancer type and select internet facing as the scheme and assign the network mapping to the VPC and public subnets. And you also assign the listener to listen to the traffic and forward to the target group. The target group will contain the web servers instance managed by your auto-scaling groups. You also define the health check for the target group to ensure instances are healthy and ready to serve traffic. And then we will do the same for the application tier load balancer. We have configured both the web tier and app tier load balancer as internet facing. The reason is that this is to lower the latency for API calls, providing a better user experience for mobile app users. In this scenario, the external mobile app users will connect directly to the application tier load balancer to consume the API service provided by the application servers without routing through the web tier. To create the auto-scaling group, first you need to create a launch campaign that has the configuration details to launch an instance in the auto-scaling group. We need to create 2 launch campaigns, one for the web tier and the other for the application tier. First, you need to define the AMI for your instance, configure the instance types, security groups, and key pairs, and add user script for any custom configurations. And then you connect the auto-scaling group to the web tier launch templates. Assign the network mapping to VPC and the web tier subnets. and then associate to the web tier load balancer. This will enable the load balancer to distribute the traffic to the instance managed by the auto-scaling group across multi-AC for high availability. And then you set up the health checks to monitor the instance health, define the conditions that indicate if an instance are functioning correctly or need replacement. I also enable the group metrics collection with CloudWatch. And then we define the desired number of the instance. Based on the business requirements, we propose to set up 2 instances running in our auto-scaling group. So we set a minimum and desired capacity of 2 instances and maximum of 6. And then we create a scaling policy to define when to scale out and when to scale in. This policy can be based on various metrics, such as CPU utilization. Finally, we add a notification by subscribing to an SNS topic. In this case, an AWS CloudWatch alarm is triggered when the CPU utilization metric is greater than 40% for 5 minutes. It triggers an action such as running an auto-scaling policy to scale out those EC2 instances. The SNS topic can be configured to send notification to your development team by email. So our application tier task will be somewhat similar to what we did in the web tier. However, it is using a different launch template, subnet, with security group on the application tier. Moving on to Amazon S3, it is a flexible and reliable storage service that can accommodate AnyGroupLLC growing data needs, making it suitable for storing product images and media without storage constraints. It offers the ability to define your own lifecycle policy to meet your data retention and compliance requirements while cutting down the storage costs. This involves strategies like moving older data to cost-effective storage class like S3, infrequent assets, or Glacier.
In consideration of our system's performance optimization, we have leveraged the power of AWS Elastic Cache to elevate our operational efficiency. We have implemented a caching system to store user session data and infrequently changing data. As the screen shown, you will notice our Radius caster configuration with cache T4G Marco as node type, which is only for demo purpose. In the real production environment, we will use the cache X7 large node type. This choice is to inform by the track record of AnyGroupLLC, which has successfully established a multi-billion-dollar supermarket chain in North America. For the initial phase of our business expansion into New Zealand, Cache X7 Large is deemed sufficient, with the flexibility to upgrade a more robust node type as needed. Additionally, you will observe that this Radius caster consists of 3 nodes. Each node represents the cache shard, which means the caching data will be distributed to be saved to one of the nodes. It reduces the Radius server pressure and enhances the Radius reliability. Although one of the nodes is down, Radius server will be still valid. Look at the rest of the configuration. We enable the auto failure to ensure the cache reliability. For the configuration endpoint, once the Radius caster is created, AWS will automatically create a Radius endpoint that we can use it to be connected by an app server to cache the user session data and infrequently changing. We also leverage the AWS DynamoDB to our NoSQL database server to our system, with some data which does not have strong relationship with other entities. We save those data to DynamoDB, like user order, which allow our system to retrieve and write the data to the database fast. We define a partition key as user ID and socket as order ID to be global unit for the user order table. We also define global secondary index called created at global index with partition key created at, which means we could like retrieve the data based on the order created date to meet our business need. Furthermore, we define like a local secondary index called create at local index with partition key user ID and socket as created at to allow us to retrieve the list of the order which is created by specific user in specific day. Considering to the database read and write capacity, we chose the on-demand capacity mode that we do not need to care about the read and write throughput. We just need to pay what we uses. Furthermore, we enable like a dynamo string. Dynamo string is that capture item level change in your table and push the changes to dynamo string. We enable the dynamo string to trigger the order notification lambda. For example, if the order is created, the lambda will be triggered. We could send topic inside the lambda implementation to S3S, so any subscribers subscribe the specific topic will be notified. Regarding to the order notification lambda, which is triggered by the dynamo string, you could use the different language to create a lambda. I use the Node.js 18 as runtime. You could write your implementation code inside the Lambda to send SNS message about user order creation to SNS. For the additional setting, we use the 128 as memory and timeout as 30 seconds because the workload inside the Lambda is small and it does not require high IPOS operation. For the runtime, memory, and function timeout chosen, you could custom them to satisfy for your business need. That's all for us. Thanks for your time.